Hey guys, how are you? Let us solve the valid parenthesis problem, which is an easy problem, but it is a very good problem. So in this problem, we are given a string S that contains just the characters bracket, open, bracket, close, curly brace open, curly brace close, and square brace open, square brace close. We have to determine if the given input string is valid, and it is valid only if the open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every close bracket has a corresponding open bracket of the same type. For example, in the example number 1 we have a bracket open bracket close. Now both are the same type of bracket open bracket close, so this is correct, right? Now we have another combination. Let us see the example number 2. We can see we have a bracket open, then it is closed. We have a bracket open which is a square brace, it is closed. Now we have another bracket open which is a curly brace, it is closed by a curly brace, so it is correct as well, right? But in the example number 3 we have a bracket open but it is closed by a square brace. This is incorrect. So in this case the output is false. For the other two cases the output is true. Let us see the example number 4. The example number 4 has this particular input. Now here you will see we have a bracket open, then another open is there. The first is a normal bracket, the second is a square brace. Then we have a square brace which is closed. So basically this square brace closed is for the open square brace. So this is fine, right? And this particular bracket is for this particular bracket. So this is fine. All the open brackets are having their closed brackets in the correct order. But when you will see the example number 5, the example number 4 is true, but the example number 5 is false, because here if you will notice we have a bracket open, then we have a square brace which is open, right? Now we have this particular bracket which is closed. This particular bracket is for the first bracket which is open, but this is not the correct ordering. You cannot close a bracket before you close the square brace, right? The square brace closing is after the normal bracket close, and that is why this is false. Now the thing is, you have to understand when it is valid and when it is invalid. So the first observation is, for a particular bracket type it should be closed by its corresponding closing brace, right? It can be a curly brace, can be a square brace, can be a normal bracket, but it has to be for its own pair. So we have to create a pair, and let's do one thing. Let's create a pair, and this pair will actually be the mapping of different brackets or different braces with each other. We can say that we have a pair which is a dictionary in which the key is the closing brace. We have curly brace, we have square brace, and we have a normal braces as well, right? And for the curly brace, the value, the output, the value is going to be the opening curly brace. For the square brace, the value is going to be the opening square brace, and for the normal bracket, the value is going to be the opening normal bracket. Now what we are getting to know from here is, if at any point we are getting this particular data, if this is the data, it means we are closing a particular bracket, we are closing a curly brace, or we are closing a square brace, or we are closing a normal bracket. If we are closing a particular type of bracket, we should have its corresponding opening bracket as well, right? And just before we are closing it. For example, if you see in the example number 4, this is correct, right? This is the correct combination of brackets, because we are opening a bracket, then we are opening another square brace, now we are closing it. At any point if I am closing a bracket, it means that there should be another open brace as well, right? We are closing here, this is the closing square brace. For closing square brace, in the line number 13 you can see that we should have this as the opening, and we have it. For this particular square brace which we are closing, the last opening we have got is this particular data, which is correct. So that is what we are trying to create. We are trying to create for a particular closing what was the opening. In the example number 5 you will see that we have an opening, another opening, then we have a closing, right? The moment we are closing, it means we should definitely have some opening as well, some opening bracket. We are closing a normal brace, but the last opening bracket was a square brace. They are not matching, because we are closing this particular bracket which is in the line number 14. It needs the last opening as this particular data, the opening brace. It got square brace, so we can directly return false. So this is the pair we need to understand our data. Now another thing is, let us say our string is starting from a closing brace. If our string is starting from a closing brace and after this it has this particular data, still it is invalid. Although you can see these two brackets are fine, these two square braces are fine, the curly brace is fine, but we are starting with a closing brace. At any moment if we are starting with a closing brace and we do not have any data before this, it means it should be a false. We will only try to close when something is open, when some type of bracket is open, right? So what we can actually do is, we can actually create something called as stack. Let's create a stack. Let's have a list for this. Now why this problem can be solved using a stack, I am going to explain you using two different input. For the first one we are going to get a false, for the second one we are going to get a true. The second string is valid. For each of the bracket we have its matching pair in the correct order, and here we are starting with a closing bracket and we do not have its opening bracket previously, right? This is the first character and that is why it is invalid. let's run a loop for C in S. We are going to access each of our character and we are going to say if length of st is equal to 0. That is if our stack is empty and the current character is in pair. Now try to understand about this particular condition. If our stack is empty, what we are actually planning with the stack is we are going to push each of our character into the stack. We are going to process it and I will tell you why a stack and what is the processing we are going to do with a stack. But as of now, try to understand this. We are going to push each of the character which are there in our string into the stack one by one. If the stack initially is empty, then definitely our data should start with a opening bracket and not a closing bracket, right? If it starts with a opening bracket, then it is fine, we can continue. But if it starts with a closing bracket, it means that we are trying to push a data which is a closing bracket and it doesn't have its opening bracket, right? So it is false. So we can directly say return false. But if this condition is not true, let us say we have another condition, elif C not in pair. That is, this particular character what we are as of now trying to receive in the loop, that particular character is not in the pair. Basically, it is going to check the keys, not the values. It means C is a opening bracket and not a closing bracket. If C is a opening bracket, we are simply going to push this into the stack. We are going to say st.append C. For example, for this true case, you can see we have received the opening bracket which is not a key in the pair. So we are going to push this into the stack. So our stack is going to have a curly brace, right? Now there is another condition, elif C in pair. Now do not get confused with the condition number 1 and condition number 2. Condition number 1 is C is in the pair, that is the current character is a closing brace and the length of the stack is empty. This condition says that the length of the stack is not empty and C is in the pair, that is C is a closing brace. For example, if we try to process this particular data and we see this particular character which is the opening bracket, it is going to push into the stack. Now next time we see this particular closing bracket, now this third condition will be satisfied. The closing bracket is a part of the pair. This particular character is a closing brace. So what it needs is, it needs the opening brace of its same type. So what we can do is we can say if the last value which got pushed into the stack, we are only going to push into the stack a opening brace. And whenever we see a closing brace, we are going to pop it out from the stack. It will look something like this. We are first going to push curly brace into the stack. Now we get the closing brace. It means we have got this. We are not going to push the closing brace into the stack. Instead of that, we are going to pop out the opening brace. It means we have processed these two characters and it is fine. Similarly, now we are going to push the next character which is the opening square brace. Next we see a closing square brace. We are not going to push this into the stack. We are just going to say what was the last pushed value into the stack. Okay, it is a opening square brace. It is my matching pair. So I am going to pop it out and I have processed these four characters. It is fine. Similarly, for these two characters, it is fine. So we can say yes, it is correct. But let us say this is curly brace. So what will happen? These two characters will be processed. Now we see a opening brace. We are going to push this opening brace into the stack. And now we see a closing brace. So as of now, our stack is having the opening brace, which is a square brace. And now we see another character, which is a closing brace, which is a curly brace. The moment we see a closing brace, we are going to pop out the value and we are going to say, okay, is this square brace what we are expecting? No, we are not expecting a square brace. We are expecting a opening curly brace. We can find it from the pair map. So that is what we are trying to achieve using a stack. We can say if this is in the pair and our stack is not empty, the expected value will be coming from the pair of C, and the actual value is going to be st.pop. We are going to pop the top value from the stack, and that is why we are using a stack, because we want to access the last inserted data, right? Now if expected is not equal to actual, it means the data is not correct. We can directly return false. Now we do not have any other condition to process. When we are out of the loop, we are not going to say return true, and the reason is there can be a condition when this can become false apart from these conditions. For example, let us say the input is opening square brace and opening square brace. What will happen? We are going to push all these two data into the stack, and our stack is going to have these two characters, and nowhere we are going to return false. But the thing is, this is incorrect, right? It needs a closing brace. Now you can observe one thing. We are actually popping out a value from the stack whenever we are finding the correct pair of opening and closing brace. We can basically say that we are going to return length of stack should be equal to 0. If this is equal to 0, it means the stack is empty and the string is correct. But if the length is not 0, it means there is a problem. The string is not correct. This will return false. So that's the complete code for this particular problem. So yes, you can see the runtime is really good. The memory used is fine as well. We are using some memory for stack, which is fine. We have solved our particular problem. So guys, that's it for this video. I hope this video has explained you the problem and the solution approach for this particular problem. And if it did, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.